No worries, Kassan. So now we're using that normal distribution that we had talked about before. So when we're drawing conclusions from samples, we're going to be finding the z-score. What the z-score tells us is whether something is above or below average. So if you have a z-score of 0, that means it's average. If you have a z-score that's above average, you could treat that like an A, for example, in class. We know that that's above average, and we know a B is above average, and C is average, and we know that D and F is below average. So when we're drawing conclusions from samples, when we get positive values, those are above average. When we get negative values, those are below average. Does that make sense? Okay, when I'm talking about the z-score, I'm talking about the formula that I highlighted. So the mean minus, or the, sorry, said that wrong. X is your data point, so whatever the question is about. Mu is your mean, and then sigma, which is the symbol on the bottom, is your standard deviation. The mean and the standard deviation are given in the question, and then they're telling you what you're comparing it to. That's going to be what you plug in for X. Cool? Okay, let's calculate the very first one. So we're doing Z equals X minus mu over sigma. X, in this case, we want to find the z-score of a newborn weighing 2,500 grams. So X is going to be 2,500. Our mean in this question was 3,250. And our standard deviation is 500. Are we cool with that? Nothing too crazy? If we put that into the calculator, just your regular desmos.com scientific calculator. Anybody need me to send that link in the chat? The regular calculator? No? Okay. So you'll type it in like a regular fraction.
Can you enter the little Q sign on the chat?
The U sign?
No, the Q one. It looks kind of like a Q.
Yeah, let me see if I can find it. I don't know if there's a keyboard shortcut for it, but I can find it. All right, there's the equation, or the, not equation, symbol for sigma. So 2,500 minus 3,250 divided by 500, we should get a value of negative 1.5. Did you guys get that? Hopefully you calculated it on your own. So negative 1.5, if we had a baby who weighed 2,500 grams and the average is 3,200 grams, then that baby's weight is below average. Does that make sense? Cool. Okay, so I want you guys to try part 2 and tell me what your answer is in the chat. So you'll do the same process. In this case, X is going to be 4,500. And tell me what you get in the chat for your answer. So far, everyone in the chat is correct. But I only have 4 answers in the chat, so I need a few more. Sosa and Jocelyn, make sure you're typing 4,500 minus 3,250 on the top of the fraction and 500 on the bottom. So use the scientific calculator. There you go, Jocelyn, that's right.
It's because you have to minus it first and then you have to divide. If not, it just messes up the whole thing.
6, 7. Are you using the scientific calculator?
No, I just use Google.
Use the scientific calculator, then you can write it as a fraction. Stop making your life difficult. Still waiting on quite a few responses, so I only have 1, 2, 3, 4, 5, 6, 7 answers. Hassan, double check your work. I have 9 answers, so I need one more. Who's my last person? Can you please send me your response? Hassan, that's right. One more response. Take your time, type it in the chat. Let me know if you need some assistance. Last person. So when we're finding Z for this one, same as before, we're still using the same formula. So this one should have been 4,500 minus 3,250 over 500. So we should have gotten Z equals 2.5 this time. 2.5. Cool? So far, so good? Nothing crazy? Okay. For question 3, we're going to have to calculate 2 z-scores, and we want to find the percentage that falls between them. So when we talked about our normal distributions before, we found the 2 bottom numbers, and we found the percentage that falls between them, right? So we're using the same, oh, I forgot, sorry. I forgot I'm not using my pen anymore because it's broken. We're using the same normal distribution, and we're calculating percentages in between. So let's calculate the z-score for 2270 and for 4230. So calculate both of those. So 2270 minus 3250 divided by 500, and 4230 minus 3250 divided by 500. Goodness, I cannot write at all.
I had one question.
Yeah.
So on Math Excel, for like the Find on the Study Guide, it would say something like those questions that would have to do with like the graphs, like those, but it wouldn't show the graph. It would just ask the question.
So that's why we practice making the normal distribution, because you have to know how to make it to be able to answer the question.
Oh, okay.
So I did send out that calculator to help you guys, and it will show the graph for you. And then if you have the questions where it says to find the exact percentage, that's at the bottom as well. So when we calculate these, we get negative 1.96 and positive 1.96. Are we okay with that? Did you guys calculate the same thing? I hope. Okay, so what percentages fall between negative 1.96 and positive 1.96? Tell me your answers in the chat. What percentages fall between those two highlighted lines? Add them all together. Sorry, I should have specified. Find the percentages and add them all together. So Jocelyn and Alexander, your answers are right. I just should have specified what I meant. Looking good. I got 3 correct answers so far. Send all of your correct answers in. The sooner you send them in, the faster we can move on.
What are we supposed to do again?
Calculate the percentages that are between 1.96 and negative 1.96. So the 2 places where I highlighted, add up all the percentages that fall in between. I can't write. I can't write at all. God, you have no idea how difficult that was to write. So I got quite a few correct answers. It looks like everyone that responded in the chat is correct. So we should have had 95%. How do we feel about that so far? Nothing too crazy? Okay. Moving on. So now we have a company that develops fertilizers wants to know whether either of the 2 fertilizers they have in development shows a significant difference in the growth of plants based on 95% confidence level. So the 95% confidence level was what we went over when we talked about our margin of error. So they give us our mean and our standard deviation. So we'll go ahead and highlight those. So our mean is 20 and our standard deviation is 1. So far, so good with that part? Great. So we want to see what is the z-score for a mean of sample treated with fertilizer A compared to a sample of bean plants without fertilizer. So I feel like I missed something. Oh, okay, there we go. Ah, that's not a highlighter. You guys, I hate this pencil. So our value that we're going to use for X is going to be 20.4. So we'll do the same thing that we did before. So I'll write out the formula. I want you guys to do the computation. So X minus mu, which is our mean, divided by sigma, which is our standard deviation. So this is going to be our value for mu, sigma, and X. Go ahead and do the work and tell me what you get as your answer. So you're going to plug in 20 for mu, you're going to plug in 20.4 for X, and you're going to plug in 1 for sigma. And then tell me your answer in the chat what you get. Genesis, you're right. So Genesis, if you want to move on to question 5, for it to be considered significant, the z-score has to be either bigger than 1.96 or smaller than negative 1.96. So would you say that that's significant? Alexander, your answer is correct. Daniel, your answer is correct. So same thing if you guys want to move on to question 5. Question 5 is saying if your z-score is bigger than 1.96 or smaller than negative 1.96, so those little small pieces on the outside, if it would fall in that area, then it would be significant. Otherwise, if it would fall in the middle, it's not significant. So it's asking you if it's significant or not. Alexis, your answer is correct. Sosa, your answer is correct. If you guys want to move on to part 5, by all means, go ahead. Jocelyn, your answer is correct. Go ahead and move on to part 5.
I forgot what the sentence frame was for number 5.
So for number 5, it's asking you whether it's significant or not. So if it's significant, it would fall between negative, or if it's not significant, it would fall between negative 1.96 and positive 1.96. So if it falls in that area, you would say it's not significant. If it falls outside of that, you would say that it is significant. Still waiting on quite a few more answers in the chat, so I don't have one from everyone yet. I only have 7 responses, and there are 10 of you, so waiting on 3 more people. Send me your responses in the chat. Okay, waiting on 2 more responses. Come on, guys, we can go a lot faster if you're participating. Making things go by slow. Send me your answers in the chat. If you're stuck, tell me that you're stuck. Otherwise, I'm not leaving you behind. Jocelyn, you're right. If you want to move on to part 6, if you feel like you answered part 5 correctly, it's pretty straightforward, so you probably did. You can go ahead and move on to part 6 and part 7. They're just like parts 4 and part 5. So if you want to go ahead and move on, you're welcome to go ahead and move on. Okay, Matthew, that's correct. So go ahead and move on to part 5. So if it's between negative 1.96 and positive 1.96, it's not significant. If it's outside of that, then it is significant. So that's question 5, what it's asking.
How do you know like what number is in what place for number 6?
So for number 6, the only thing that you're going to change is x, because the mean and the standard deviation are still the same. So that mu, that fancy u, and then the sigma, the little o on the bottom, those numbers are still 20 and 1. So I'm still waiting on one more response. Hopefully Jose will message me back in the chat right now. But we should have gotten 0.4. So 0.4 would fall about right here, which would fall inside of that range. So we would say that it's not significant. I wish I could write more. We would say it's not significant because it's between negative 1.96 and positive 1.96. We want the ones to be outside. Those are significant. Cool. Ready to move on to part 6? So part 6, we're doing the same thing as part 4. So now our new average is 20.3. So that's what we're going to plug in for x. So calculate that and tell me what you get in the chat. Mean and standard deviation are still the same. Genesis and Daniel, you're correct. So if you want to go ahead and move on to part 7, you can. So part 7 is just like part 5. Alexander, you're correct. If you want to move on to part 7, you're welcome to. Jocelyn, you're correct. Genesis, you're correct. Alexis, you're also correct. Sorry, I didn't see that you responded. Gassan, you're also correct. So if you guys want to move on to the part 7, part 7 is similar. You're doing the same thing that you did for part 5. Jocelyn, you are correct. Copy, paste. So we should have gotten an answer of 0.3, right? Once we have that answer of 0.3, it's asking you if that's significant. 0.3 is going to fall in that range again. So if we have negative 1.96 and positive 1.96, 0.3 falls somewhere in the middle. So we would say it's not significant. Based on these data, would you advise the company to market fertilizer A or fertilizer B? So which one would you prefer using those? Remember that your Z-score tells you how far above or below average something is. So would you use fertilizer A or would you use fertilizer B, and why? If you need help, tell me in the chat. So, Jocelyn, your answer is good. Genesis, your answer is correct. Sosa, yes. I'm going to give you guys about 1 more minute to write that answer. So based on your answers for your Z-scores for fertilizer A and fertilizer B, which one is more above average? So which one would you recommend? Chrisman, your answer is correct. Wait, Genesis, your answer is not correct. Gassan, your answer is correct. Genesis, I just responded, but yeah. Okay. So we'll go ahead and move on. So now we're calculating Z-scores when we have a proportion. So just like before, there were 2 different scenarios that show up in calculus statistics. One of them is when we have a mean and one of them is when we have a proportion. So for calculating for a proportion, we're using this super fancy formula. I know, it's crazy, right? Square root of P times 1 minus P over N. So I'm going to put the formula in the chat just so you can make sure that it formats correctly, and then we'll change all of the values. So if you're using the Desmo Scientific Calculator, you're just going to copy and paste over that formula, and then we'll change out the values. So we want to develop a simulation for answering 40 questions. So pretend you're answering 40 questions. Tell me what your answers are. True or false? Like literally just pick true or false 40 times.
True.
True. Okay, that's 1. You guys are bad at this. Thanks, Chrisman. So literally just type in T or F, any combination of that, 40 times. Do you just want to go true, false, true, false, true, false? Sosa just went all true. All true. It could be whatever you want. I'll just switch off between true, false, true, false. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 36, 40. Cheated a little. So the z-score based on your trials, right? Are you hearing me on this one? We want to figure out how many of them are correct, right? Yes? Okay. So we're going to assume all the ones that are true are correct. Are you ready for that? So count how many you had that were true out of the total. So I had 20 out of 40. You might have had a different number. Hopefully you had something other than 0.5, but I understand if you had 0.5. You got it? Everybody got their value for P? Okay. So you counted 19 on mine or yours?
Uh, 19 trues
On mine or on yours?
on mine.
Okay, that's fine. You should all have different answers, so that's totally fine. So you're going to do 19 divided by 40 because there were 40 altogether, and then change that to a decimal. So that's going to be what you plug into that formula for P. What we plug into P hat is what this says in the question, that we're using 1/2 as the population proportion, or we're using 0.5. So P hat is going to be 0.5. P is going to be whatever you calculated. Does that make sense?
Yeah, but for the decimal, do we round up if it's like 3 places?
Yeah, I would round just to 2, just to make your life a little easier for calculating. So for mine, it's 0.5 minus 0.5 over the square root of 0.5 times 1 minus 0.5 over 40. Yours is probably going to have a different value here, here, and here. Does that make sense? So go ahead and calculate yours and then tell me based on that z-score if it's significant or not. So the same thing falls for significant. If it's bigger than positive 1.96 or smaller than negative 1.96, it's not significant. If it's in between or it is significant. If it's in between them, then it's not significant. If you need help calculating, let me know.